Hello everybody, welcome to this vlog. My name is Satya. So today I will discuss about border gateway protocol and its use case, right? So in the last three classes, or in the last four classes I should say, routing protocols in general was described. So I described IGP protocols, OSPF, ISIS. Then I described BGP, which is a border gateway protocol. Then I told why OSPF is not preferred in ISP networks. Then I told about why intermediate system is preferred in ISP networks within a single autonomous system, and how BGP plays its preference in internet connectivity. So let's see what is the use case for BGP. BGP stands for, as I told, Border Gateway Protocol. Most of the traditional IGP protocols like OSPF, Route Information Protocol, intermediate system determines or gives an output what is the shortest path. It applies some algorithms to provide the shortest path first. But BGP applies economics to the routes. It is policy based. It tells which route is more useful or more cheaper or more economical than the other routes, right? So BGP is policy based protocol. Then we discuss about customer traffic over peers, how it is carried. What BGP helps in is BGP helps in avoiding costly links. So it helps in making the packets traverse through low cost links, right? So that's why I said it is policy based. BGP is not a protocol which will give you a shortest path output. It is a path vector routing protocol. It is used to exchange routing information between autonomous systems. Now the question here is, I described in the previous classes also, what exactly is autonomous system? Autonomous system, let's consider an example like Airtel Geo network, right? So Airtel is one ISP and Geo is another ISP. These are autonomous systems. A lot of IGP protocols will be configured in these ISPs to exchange the routing information. But the path between these two peer autonomous systems like Airtel and Geo is advertised using the paths, and that protocol is BGP. It's called as eBGP. So to re-stress or stress on the key points, BGP is path vector, not link state. OSPF, ISIS advertises what is the type of route and what is a metric used for that route, and what is a topology that is being put in place for that particular route. All this elaborate information is given in IGP protocols. And as I discussed in the previous classes, OSPF is more elaborate than ISIS. So autonomous system is identified by a ASN number. So each, for example, Airtel has one ASN number, Jio has another ASN number. What is the application of eBGP? eBGP is used to connect between two different autonomous systems. It is used on the internet, enforces policy and trust boundaries. As I told, it advertises weight and all those things which determine which path is more economical than the other, so that it applies economics and prepares a best budget path for a particular packet. iBGP. IBGP means internal BGP. So it uses help of OSPF and ISIS to send the packet to the destination, right? So IBGP requires OSPF or ISIS to function properly. How BGP neighbors form? Like for example, two routers, for example, one in Airtel and other router in Geo network, they establish adjacency using TCP protocol and the port number is 179. Explicitly, neighbor configuration has to be configured. That means a router on the Airtel side and the router on the Geo side should be explicitly configured with the neighbors. They should be configured explicitly as they are neighbors, right? So what are the different BGP states? Each protocol has different states. BGP as idle, connect, open send, open confirm and established. Only when the state is established, routes are exchanged or the paths are exchanged. Path information is exchanged. This is unlike OSPF IS where link state is sent across the routers. No auto discovery, no multicast, fully controlled. So this is what is put in BGP. No auto discovery, no multicast and fully controlled is what BGP is. If you have to say OSPF IS, it is auto discovery using hello packets. Multicast is sent, the hello packets are sent to the multicast address and fully controlled. Then the most important thing, I told routes, paths are advertised using BGP. What exactly BGP advertises? BGP advertises network prefixes, attributes describing the path. So I'll discuss what are the different attributes in later in this video. It does not have link cost, bandwidth, topology. It's not elaborate. It only tells what is the type of path it is. What are the key BGP attributes? AS path, autonomous system path, prevents loop. Next hop, what is the immediate next hop? Origin, from where it got initiated, the route, the path. Policy and decision attributes, local preference, med, community and weight. Local preference is used for outbound path preference. Med is inbound hint. Community is tagging routes and weight is local preference. BGP route selection, how the BGP route selection path is done. Highest weight, highest local preference, shortest AS path to prevent the loops, lowest origin, lowest med, eBGP over iBGP, lowest IGP cost to next hop. These are the attributes that determine the BGP route selection. Why BGP scales so high, so well? It's because it only sends incremental updates. If there is a change in the path or the route, then only it will send an update. It will not keep on sending every few seconds update, a link state advertisement. So it does not flood the topology. Why BGP is used in internet is because it has stability over speed. IGP protocols are speed. They are very speed in convergence. But BGP is slow in convergence, but it has stability. Number of failures in the network is less when you implement BGP in the internet. Why BGP needs or IBGP needs OSPF and ISIS? BGP knows which prefix and which next hop. How to reach it is determined by using IGP protocols like OSPF and ISIS. So in simpler words, BGP decides the path, IGP delivers the packets. Real world use cases, ISP to ISP, data center, enterprise multi-ISP connectivity, failover control. Simple model. OSPF ISIS determines using algorithm what is the shortest path. BGP determines which path to prefer, and IGP is then used to get to that path. So that's why IBGP is always reliant on OSPF and ISAS, but eBGP is only reliant on what path to be advertised using the attributes. Common misconceptions that is relevant to BGP. BGP is not only for ISPs. BGP is not faster than OSPF. These are the misconceptions. BGP does not replace IGPs. BGP does not calculate topology. BGP is about control and policy-based routing. Very simple example. Let's consider autonomous system 100, autonomous system 200, autonomous system 300. They are serially connected. Now using BGP, we can say that autonomous system 200 can say that outbound path should always be AS 100, autonomous system 100. But it can say that don't prefer AS 300, right? Or advertise the paths for AS 300. So final takeaway from this training is BGP is policy based, works between networks, that is autonomous systems, scales to millions of routers because of less CPU power utilization, and its convergence is slow, trades speed for stability, works with IGP, especially IBGP uses IGP protocols like OSPF and ISAS to advertise the routes to reach the final destination. So this is what BGP in a nutshell is. To summarize, BGP is border gateway protocol. It is a policy-based, trust-oriented path or route discovery protocol. It determines what is the best path to reach the next stop. It is usually used between autonomous systems, like Airtel is one autonomous system and Jio is one autonomous system. It advertises the paths or routes between these two autonomous systems. But IBGP is using IGP protocols like OSPF and ISAS to determine how to reach to this next stop, right? So it is used in so IBGP always works in conjunction with other IGP protocols. So this is what I wanted to discuss, friends, as part of this particular vlog. So if you have any questions, please put a comment. If you like the video, please press the like button. Thank you. Bye.